So the last time I saw you, we dealt with reference angles and how to find reference angles. And now we're going to be talking about evaluating trig functions of any angle. Evaluating trig functions of any angle. Keep in mind, this will not be calculator math. There is a section in here of your homework, and it specifically tells you not to use a calculator because I want you to see the work. I want you to show me the work of getting there. I don't want you to just plug it in and get the calculator answer. So if you just give me an answer, I'll just have to give you a 0, and I don't want to do that. So the first step would be to determine the function value of the associated reference angle. And we'll, as usual, go over this. Determine function value of associated reference angle. Theta prime. Remember, we were calling the reference angles theta prime, which is just theta with a little mark over it, a little hash mark. Depending on the quadrant in which it lies, this is the important part of what we're doing. Depending on the quadrant in which it lies, apply the appropriate sign to the function value. I'm going to mess this one up. I think it's 2 p's inappropriate. Well, technically 3. Apply appropriate function, appropriate sign to the function value. What does all that mean? Well, what that means is we are dealing with things that aren't necessarily going to lie in that first quadrant where everything is positive. So say I forgot to write down what the direction was on that when I did my notes. Like I did the evaluation part and forgot to put So we just want to evaluate these trig functions. Evaluate cosine of 4 pi over 3 and tangent of negative 210 degrees. We'll call this A. We'll call this B. And C we'll call cosecant of 11 pi over 4. And we want to evaluate each of these trig functions. So what we first need to do is determine which quadrant they lie in, right? So let's start with A. We'll go cosine of 4 pi over 3. Well, we know that 3 pi over 3, right? If I had a little graph here, this is pi. 3 pi over 3 would be pi. So 4 pi over 3 is going to lie somewhere in here, right? Doesn't matter where. I'll just call it 4 pi over 3. I know it's in the third quadrant. What I know about cosine is that cosine is the x value. And in quadrant 3, in this third quadrant, I know that the x values are negative. That is why I need to know which quadrant it's in, right? So I know in this case, I've got my x's are negative and my y's are positive, and we're asking for cosine, and cosine is x, right? So if cosine is x, I know whatever answer I'm going to get for this is going to be negative, just by what quadrant it's in. So the first thing I need to do is I need to find its reference angle. And if you remember, anything that's in quadrant 3, we would take to find our reference angle, we would use theta minus pi. And in this case, our theta is 4 pi over 3. Gosh, man, I love when it does it when I'm making the box, but man, not when I'm trying to. 4 pi over 3 minus pi. Well, that's the same as saying 4 pi over 3 minus 3 pi over 3, right? If I just want common denominators. And that just gives me pi over 4. I don't know where I got the 4. It's a 3. Maybe I was looking at this 4. I don't know. So that's my reference angle. My reference angle is pi over 3. And now I need to find the trig value at pi over 3. Now, I implemented in I put into your PowerSchool a photograph of different trig functions. I'm going to put it up in here too. Let's see if I can make it big enough for you to read. I put it in there. It's just these trigonomic values of common trigonomic functions at your main points, right? So we can just look at this chart and we can go, well, what is cosine at pi over 3, right? And cosine at pi over 3, because that's what we're looking for now, right? Is if we do cosine of 4 pi over 3 is the same as negative cosine of pi over 3. Keep in mind, we're saying negative because of what quadrant it's in, right? And if we look at that, we know it's going to be negative whatever cosine of pi over 3 is. So negative 1/2. This chart will really help you with your main angles. If you don't have a unit circle in front of you, because we didn't get to build them this year because you're not in my classroom, maybe if you get back in my classroom, we'll build one. This chart is super handy for figuring out your main trig functions, right? We know we've got to apply the negative because cosine is x, right? And in this quadrant, all of our x's are on the negative side. So once we figure out it's just cosine pi over 3, all we have to do is apply the negative to whatever that function value is. Does this make some sense? If it doesn't, it's okay because you're going to see multiple examples. Just checking the chat box here to see where you guys are standing on it. So this negative 1/2 is our solution. See, that time I like when it made the box. That was convenient. So let's look at our next one. Our next one is going to be tangent of negative 210 degrees. So let's look at B. B is going to give us tangent of negative 210 degrees. This time we aren't working with pi, right? We're working in terms of degrees. But we can still figure out what quadrant we're in, right? We know that we're going to go 210 degrees in this direction. Well, this is 180. This would be 270. So 210 is going to be in here somewhere, right? Negative 210. But we don't want to know what the negative is. So we're going to have to find the coterminal angle first, right? And if you remember, finding the coterminal. So first we want to find the coterminal angle to get our positive. And then that, all we have to do is go 360 minus 210, and we're going to get 150 degrees, right? So once we know that this is 150 degrees, we can start working towards finding the value. So the first thing we need to do is find our reference angle, right? Our theta prime. Now, I don't know if you still have the little chart I gave you or that I made for you by which quadrant it's in, but if it's in quadrant 2, we use this theta prime equals pi minus theta to find what our reference angle is. So in this case, we're going to go, it would also be, or when it's degrees, 180 minus theta, because this time we're in degrees. So we would go 180 minus our theta, which is 150, right? Which gives us 30 degrees. So now we're just looking for the tangent of 30 degrees. So we could write this as the tangent of 150, or negative 210, negative 210 degrees equals the tangent of 30 degrees. Now I want you to think about tangent in this perspective, right? Tangent is sine over cosine, or y over x. And in this case, one of those is negative, right? We have a negative x. So this whole tangent is going to be negative, right? Because they're not both negative. We've got a positive y, right? Here we've got x is negative, y is positive. And so if I have x over y, if I have y over x, I have a positive over a negative, which gives me a negative solution. And so now all I have to do is look at my chart, and I go, well, what is tangent of 30 degrees? Well, it's radical 3 over 3. And so I can just write in equals negative radical 3 over 3. Does that make some sense? I've got another one for you, but I just want to know if you're kind of following along now, if I need to do some further explaining on it. All good? Okay. Let's move this sucker down with us because it's kind of helpful, right? So our next example is C. We've got cosecant of 11 pi over 4. Well, if you think in terms of the math of 11 pi over 4, 4 goes into 11 twice with 3 left over, right? Like 8 pi over 4 is 2 pi. That's 2 full trips around the, right? If I am starting here, this distance right here is 8 pi over 4, right? So we would have to go another 1, 2, 3 pi over 4 to get to this quadrant 2. Now, I'm just showing you that on this, but there's a way to find it mathematically that we've gone over before when we're dealing with coterminal angles. And we could just go 11 pi over 4 minus 2 pi, and we would get 11 pi over 4. When I get my common denominator, it would be minus 8 pi over 4, and we would wind up with 3 pi over 4. And so we know if we divide this into fourths, this is going to be at a 45-degree angle. So this is 11 pi over 4, but it is also 3 pi over 4. They are the same angle. So now that we know that we're dealing with 3 pi over 4, when we find our reference angle, we can use the 3 pi over 4 instead of the 11 pi over 4. We know that it is in this second quadrant. So you go back to your little chart from the other day. What do I use when it's in that second quadrant? And we use pi minus theta. So in this case, we would be using pi minus 3 pi over 4. Dang it. Which is like saying 4 pi over 4 minus 3 pi over 4, right? Which just gives us pi over 4. What sign is this pi over 4 going to have in terms of cosecant? Well, if you remember, cosecant is just 1 over sine, right? And sine is y, right? Our y value. So this is like saying cosecant is 1 over our y value. And in this circumstance, y is positive, right? Everything is above the x-axis, so our y is positive. So we're looking at a positive. Does that make sense to you? So now we have to still go and find the value, but we're looking for the value of cosecant at pi over 4. So now we can solve that. We can go, okay, cosecant of pi over 4 is going to be positive, right? Not negative. It's going to be positive. Is the same as saying cosecant of 11 pi over 4 is the same as saying cosecant of positive pi over 4, which is the same as saying 1 over sine of pi over 4. And if we look at our chart, on down here, little chart, sine of pi over 4 is just radical 2 over 2. So we're saying that it's 1 over radical 2 over 2. And now we just have to do our crazy math, right? Where we go, okay, 1 times the reciprocal, 2 rad 2, which is 2 over radical 2 when we multiply them together. And we have to get rid of that little bugger. So we get 2 rad 2 over 2 is what that equals. And then these cancel. We just get radical 2. Does that make some sense to you? Before we start doing the problem, could we find an angle like 3 pi over 4? Well, isn't that kind of what we did, though? Oh, okay. So yeah, that's what you're doing, right? You're making, because it went around more than once, we got to find that one angle. I don't think they're going to get any more difficult than this in the homework. Let me go over trig identities, and if we still have a little time afterwards, then I'll try and find one in the homework that we can do that might be a little bit more difficult. The main thing is when you're doing it, I put this chart into your PowerSchool. Use it. It's really helpful. You can find it anywhere on the internet too if you because once you get to this point, then it's just going to give you the value. But ultimately, we're just finding reference angles, just like we were on the last homework, right? It's just sometimes you have to get some work to figure out where you are on it, to figure out. All we're doing that's different from the last time is we're figuring out where that lands and applying a sign to it. We're still just finding reference angles, right? And we're just applying a sign to it and then figuring out where the chart gives us the rest. So I can't imagine it'll get much harder. But after I do the trig identities portion, which shouldn't take us too long, we can always go back and do some more problems. I can find some. So now we're going to be using trig identities. And we've done this before. All of your previous identities, if you remember, I hope you still have in your notes all of the trig identities that we have done. Identities to solve, right? That's why we're not saying calculator. I want to see your work. I want to see the identities that you use and how you applied them. So we're just going to do it by example. We're going to let theta be an angle in quad 2, an angle in quadrant 2. Think about that. If I have an angle here in quadrant 2, I know that my x values are going to be negative, my y values are going to be positive, right? So depending on what they're asking for, right, if I have cosine, it's going to be negative. If I have sine, it's going to be positive. Tangent would be negative, right? Secant, because secant is part of cosine, right? That would also be negative. Cosecant would be positive, and cotangent would also be negative. Does that make some sense? What I mean by just knowing what quadrant it's in allows you to know the sign. So let theta be an angle in quadrant 2 such that sine of theta equals 1/3. And we want to find A, cosine of theta, and B, tangent of theta, using trig identities. That means no calculators. And I will know because you won't be able to show me your work if you don't. I totally spelled identities wrong. But let's think about this. We're looking for cosine. If we look at A, we are looking for cosine of theta. We know what sine of theta is. So we need to go back to that trig identity page. Now, this one works really well with the Pythagorean identity because we have one. Let's put cosine theta here is what we're looking for. We have one of the Pythagorean identities that says that sine squared of theta plus cosine squared of theta equals 1. And this is a really handy one for us because we know what sine of theta is, right? Sine of theta just equals 1/3. So we could plug in 1/3 squared, because that's what sine squared of theta means, right? Plus cosine squared of theta, which equals 1. And we can just go ahead and solve for cosine at this point, right? Well, 1/3 squared, that just equals 1/9, right? 1 squared is 1, 3 squared is 9, plus cosine squared of theta equals 1. So now we just need to start solving for cosine of theta. We're going to start by subtracting 1/9 from both sides. That is the same as saying cosine squared of theta equals 9/9 minus 1/9, right? Which is just 8/9. We can go ahead and say cosine squared of theta equals 8/9. Now I can solve this by taking the square root of both sides, right? If I take the square root of this and the square root of this, I get cosine of theta, which is what we are trying to find, right? That is our A, equals, well, the square root of 8 is 2 radical 2. If you need to see the breakdown of that, 8 equals 2 times 4, which is 2 times 2. So I could pull the pair out, but I still got to put the other 2 underneath. And then the square root of 9 is just 3. What did we determine was the sign of this problem? Right? Cosine is y. So if we were searching for cosine up in here in this quadrant, we have to apply the negative to it. So we found the value we need to put in. The sign is negative. That makes some sense? Yes, no? I know we're going back to the last unit the last section where we were talking about our trig identities, but all this stuff does come back to haunt us. So let's look at tangent. Well, tangent's not so hard dealing with trig identities, right? If we do B, tangent of theta, what I know about tangent is that tangent is sine of theta over cosine of theta. And the reason that is handy is that we know that cosine of theta equals this sucker, right? And we know that sine of theta from the beginning just equals 1/3. That part was given to us. Tangent is going to be negative. We already determined that. So no matter what we get here, we know that our solution is going to be negative. So I'm just going to put that out there. Negative. Sine of theta is just 1/3. It was given to us, right? Cosine of theta, I'm not going to write in this negative because, oh, well, I am going to write in this negative. But cosine of theta is just going to be 2 rad 2 over 3. I don't know why I'm saying 3. Is it? Yeah, is it 3? Yeah, it's 3. So now I have to solve this crazy fraction, but it's really not that crazy because we just multiply times the reciprocal. So we wind up with negative 1/3 times radical, 3 over 2 rad 2. When I look at that, these can cancel, and we wind up with 1 over 2 radical 2. We need to rationalize that denominator, so we're just going to multiply times radical 2 over 2, and we get radical 2 over 4. And I lost my negative along the way, but it still needs to be there, right? So that one was slightly more difficult, but it wasn't super difficult. If you know how to do your reference angles, you'll be fine. Because once you can do your reference angles, you can apply the values. On this one, this is just going back to your trig functions, and now we're adding values to it. So you're going to have to plug in the numbers once you use your trig identities and solve them. The hardest thing that you'll get is a fraction over a fraction, right? And you know how to handle a fraction over a fraction. You just multiply by the reciprocal of the bottom one. Any questions on that? All right, I'm going to stop the recording right now. But